JEE Advanced 2025, Paper 2, Physics, Question 11. Here is the volume versus temperature diagram for the cycle. The gas starts at point W with volume 64 cubic centimeters. It undergoes an adiabatic expansion from W to X, reach ing volume 1 to 5 cubic centimeters. Then an isobaric expansion from X to Y, where volume doubles to 250 cubic centimeters. Next, an adiabatic process from Y to Z. Finally, an isobaric compression from Z back to W completes the cycle. The question states, an ideal monatomic gas of N moles is taken through a cycle WXYZW, consisting of consecutive adiabatic and isobaric quasi-static processes, as shown in the VT diagram. The volume at W is 64 cubic centimeters, at X is 125 cubic centimeters, and at Y is 250 cubic centimeters. If the absolute temperature TW at point W satisfies nRTW equals 1 joule, find the amount of heat absorbed in joules along the path XY. This is a numerical answer type question with +4 marks and no negative marking. Let us recall the key concepts needed for this problem. First, for a monatomic ideal gas, gamma equals 5/3, Cv equals 3R/2, and Cp equals 5R/2. Second, for an adiabatic process, T times V raised to gamma minus 1 is a constant. Here gamma minus 1 equals to over 3. There is no heat exchange in an adiabatic process. Third, for an isobaric process, that is constant pressure, V over T is constant, which is Charles' law. The heat absorbed is Q equals Ncp delta T. Step 1. Find the temperature at X using the adiabatic relation. For the adiabatic process W to X, T times V to the power gamma minus 1 is constant. So TW times 64 to the power 2 over 3 equals Tx times 125 to the power 2 over 3. Now, 64 to the power 2 over 3 equals 4 cubed to the power 2 over 3, which is 4 squared, that gives us 16. Similarly, 125 to the power 2 over 3 equals 5 cubed to the power 2 over 3, which is 5 squared, giving 25. Therefore, Tx equals Tw times 16 over 25. Step 2. Find the temperature at Y using the isobaric condition. For the isobaric process X to Y, V over T is constant. So Ty over Tx equals Vy over Vx, which is 250 over 125, equal to 2. Therefore Ty equals 2 times Tx, which is 2 times 16 over 25 times Tw, giving us 32 over 25 times Tw. Step 3. Calculate the heat absorbed along the isobaric path XY. For an isobaric process, Q equals Ncp times delta T, that is N times 5R/2 times the quantity Ty minus Tx. Ty minus Tx equals 32 over 25 Tw minus 16 over 25 Tw, which is 16 over 25 times Tw. So Q equals 5 over 2 times 16 over 25 times nRTW. We are given that nRTW equals 1 joule. Substituting, Q equals 5 over 2 times 16 over 25 times 1, which is 80 over 50, equal to 1.6 joules. The correct answer is 1.6 joules. This is the heat absorbed by the monatomic ideal gas along the isobaric path from X to Y. Here are important tips for thermodynamics problems in JEE Advanced. Tip 1. For a monatomic ideal gas, gamma is 5/3, Cv is 3R/2, and Cp is 5R/2. Memorize these. Tip 2. In adiabatic processes, use Tv to the power gamma minus 1 equals constant. Always identify gamma minus 1 first. For monatomic gas it is 2 over 3. Tip 3. Perfect cubes like 64, 125, and 27 make fractional exponent calculations very clean. Recognize these patterns quickly. Tip 4. For heat in isobaric processes, use Q equals Ncp delta T. For isochoric, use Cv instead. Never mix them up. Tip 5. Express all intermediate results in terms of the given quantities. Here, writing everything in terms of nRTW made the final substitution trivial. If you found this solution helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next video.